There will be no edits, no intros for this week, only because I was at the parents' home for the weekend to celebrate my 19th birthday, and it felt like a fever dream, so it felt weird. But anyways, now I'm at my home, and just read the problem by yourself. Pause the video because I have no time. So if you're in my Phys 251 class, then we are learning about radial acceleration as a part of circular motion. So as you can see, this 4,000 revolution per minute is kind of sus because the SI unit for centrifugal acceleration or any kind of acceleration in circular motion is not revolutions per minute. We have to turn this into radians per second. Going home after being in college for a long time, it felt like a fever dream, and me turning 19 on Sunday just adds to that fever dream. So that's why I don't have much time to edit some stuff in. So for example, we need to convert the 4,000 revs per minute to radians per second. So, anyways, I got 418.87, 88, excuse me, from multiplying 4,000 revs per minute to with a 2 pi radians per rev. You can remember this by saying that the Bolsheviks led the Russian 2 pi radians to have the Russian Revolution, and yes, and I guess it cancels the revs. So now you're just stuck with radians per minute. Now you have to get them. Now you have to cancel the minutes. And in order to do that, the minutes have to do some. The minutes have to do some weird bad thing on YouTube. So, for that to happen, you have to remember every 60 seconds in Africa, a minute passes. Let us stop this. Thank you for your time. By the way, that's a reference to another meme, so yeah, please don't cancel me if you don't understand. So, anyways, there's 60 seconds in a minute, so that means the minutes can freak off. So, yeah, and with that, you get about 418.88 radians per second. So now we converted this the 400 revolution radians per second. Now we have omega, which we will use to calculate so it's asking for the acceleration of the test tube, which implies that since the test tube is going to go in the direction of the circle, it will be tangential. So so yeah, we have 10 centimeters given or 0.1 meters. We're gonna speed run this. So anyways, in order to get the tangential acceleration, we have to turn radians per second to meters per second. And in order to do that, we have the acceleration equals velocity squared over r. We do have r, however, we do not have velocity. This is tangential velocity. So as you can see, in order to do that, we have to substitute a circular motion inside, like so. Semicolon v if tangential velocity equals the radius times angular velocity, which is an omega, not a w. So what we can do, we can plug this in for v, which I did here. So but then here the one of the r's cancel in both the numerator and the denominator, which just leaves that acceleration equals r times omega squared, and we can plug in numbers after. Okay, so we are looking for the magnitude of the acceleration for part B, as being drawn from a height of 1 meter and a 1.0 millisecond long house with hard floor. So we have an acceleration equation. So a equals delta v over t. So delta v in this case is v final minus v initial. We have the v naught in this case, which is 0 since it's not moving before it gets dropped. So yeah. So we're looking for the final. So in order to do that, we have to square the velocity final, which I forgot to final, and make that equal to the initial velocity squared plus twice the acceleration on y times delta y, or in this case, y final minus y initial. So yeah, well, we are also given that the acceleration at we are going to assume that this test tube is being dropped on Earth. So basically, the acceleration at y will equal g or negative 9.81, and there's more numbers to that. It's not 10. Okay, I do not have enough time for these. Okay, so I plug in a number for you guys. So remember v naught is 0, so it's 0 plus 2 times g, which is negative 9.81 meters per second squared, times 1 meter, which is the change in y. Since y final is 0 it is just 1 meter, and then y initial is just 0 meter, so the change in y is just 1 meter. So 1 meter in the multiplication of the 0 in the addition just goes away, basically. And now you just have to multiply these two numbers, and then because it's v squared, you have to get the absolute, and we're only looking for the magnitude, we have to get we only have to get the positive since we're looking for the absolute value of this number. So you have to get the positive square root, which I got 4.43, which I rounded by just putting it down to significant digits. So after that, you plug in 4.43 for v final, and then you subtract it from v naught, which we already know v naught is 0, so we don't need to worry about this. And now we plug in t, which is 1 millisecond. But then we do know that there are 1 times 10 to the negative 3 seconds in a millisecond. So that means the milliseconds can cancel out, and then basically the top part just gets multiplied by 1,000. So the answer would be 4,430 meters per second squared. But there's only 3 significant digits. So So since we have to sim for the significant digit rule, we have to put this in scientific notation. So it's 4.43 times 10 to the third power meters per second squared. And this is your answer for B. Thank you for watching. Please drop a dislike. Dislikes, no likes, please.